9-2 homework, example problem 9-2 homework number 19. A 4.00 kilogram model rocket is launched, expelling 50.0 grams of burned fuel from its exhaust at a speed of 625 meters per second. What is the velocity of the rocket after the fuel has burned? Hint, ignore the external forces of gravity and air resistance. Okay, here we have, instead of having a collision in this case with conservation of momentum, we are having what is referred to as a recoil problem. In this case, we have the rocket on the left right here with a mass of 4 kilograms plus the 50 grams of gas that's going to be burned out and shot out the bottom of the rocket, that is currently sitting on the ground at a velocity of 0 meters per second. Now, when the fuel burns, the rocket goes up. The burned fuel pushes gas down at the bottom, which causes the rocket to go up. Now, we do not know the velocity of the rocket, but we do know that the velocity of the gases being expelled is 625 meters per second down. Leading us to a conservation of momentum problem. In a recoil problem, the total amount of momentum at the beginning of the problem is 0 because it's not moving. And afterwards, we have P1 plus P2. What this essentially means is that P1 and P2 will be equal to each other, just traveling in opposite directions. First step we have to do from a calculation standpoint, however, is change our mass so that we are all in kilograms. We had 50 grams of expanding gases that were after fuel was burned. Changing grams to kilograms changes 50 grams to 0.05 kilograms. Plugging those in, we have 0 kilograms times meters per second on the left, and then I have 4.00 kilograms times V1 for P1, and I have 0.05 kilograms times 625 meters per second for M2 V2. Since I used positive 625 meters per second, inadvertently I ended up making down the positive direction. When we multiply this out, 0 is still 0, 4 times V is still 4 times V, and 0.05 times 625 is 31.25. When I subtract 31.25 from the right and the left, it cancels on the right, making the left negative 31.25 and the right 4 times V. Dividing by 4 kilograms, 4 kilograms will cancel on the right, and negative 31.25 divided by 4 is negative 7.8125. Rounding to 3 significant figures, as we began this problem with numbers of 4.00, 50.0, and 625, all of which have 3 significant figures, we get negative 7.81 meters per second. That is number 19, recoil problem. You will have new notes coming out soon on two-dimensional momentum.